name of a band?
We have band.
Band. Everything you are doing is around band. What about
shirt? Your shirt a lot.
Yes,
hello? So, what is Hooke's law? Sir? Whose law says F is proportional to F is what? What is F? You to go and read about elastic limit, right? What is elastic limit? Put it anyhow. Elastic limit, it is the limit that the elastic material cannot should exceed. When you exceed the elastic limit, it leads you to breaking point. Is that okay? So if you are drawing a spring and you are dragging it and you are dragging it and you are dragging it and you are through extending it and you are still applying force, the next thing that will happen is that you have a breaking point. Is that okay? And we have the graph for it. Force to extension, and you see something like this, and they'll be explaining for you the elastic limit, the breaking point, and the rest. Is that okay? All those are theory which I already asked you to go and read, and I hope you all have already done that. Is that okay? Is that okay? Let's move forward. If F is proportional to E, it will say F. Sorry. F is proportional to E. It means that F is equal to KE. Where K is what? Constant. Are we together? Where K is equal to what? KE. And K, you can write this K K is the force constant or stiffness. You can come in. Or stiffness of the material. I'm coming back. We are talking about elastic properties of solid. Whatever I'm doing, I'm just paraphrasing. I'm not taking the whole thing because we have a lot to cover. That was the reason why we were able to do reflection, refraction, and enter a wave the other day. We were really fast that day, and I love that speed. And I want us to have same speed today. And you know that F is equal to what? W. And you should know that their unit is what? In Newton. Ola, is the secretary in the office already?
No.
Because we need to refill this marker.
Not around.
She's not around.
Yeah, you can give this bottle.
You can help us refill it, right? Can you help us refill it? I will not run from the class. So, F is equal to W, and W is equal to what? W is equal to what? Mg. Therefore, F is equal to mg. Where m is what? Mass. And g is equal to what? The value for gravity is what?
10.
We go to Young modulus. Young modulus states what? What is Young modulus? Is equal to what? Tensile stress over tensile strain. So strain is what? Stress is what? The formula for stress is what? Force over area. Are you sure? Yes. Stress is force over area. And strain is what?
Z over L.
Don't confuse yourself. That is sometimes we say L over E, E over L. Don't confuse yourself, please. Extension is strain is extension all over length. And then all these parameters, I hope you all know what they stand for. F is what? A is what? Cross-sectional area, right? Then we have E is what? I already explained extension to you. This is the original length of this marker, right? If this marker is an elastic material, and if I should try to apply a force, it will expand. And when it's expand, you have an extension. Is that okay? So the strain now is the extension all over the length. If you are having the length to be 10, and the extension is 20, it will be what? 20 all over 10. You'll be able to get 2, right? As your strain. Is that okay? Please, it's good you know this formula. If you don't know it now, they can ask you, you can say it's length all over strength. All over strain, you say 10 all over 20. And at the end of the day, you'll be having something else. Is that okay? Are you sure? So your modulus is what? Tensile stress all over tensile strain. And tensile stress says what? Force all over cross-sectional area. While strain is what? Extension all over length. So we are going to impute this formula in this write-up. And then if we are going to do so, our Young modulus, am I calling it well? Is it Young modulus?
Yes, sir.
I'm learning English from you. I'm teaching you physics. So anyone I'm not correct, please, I stand to be corrected. If you having this, it's equal to what? F all over A, right? All over having what? E all over L. We're going to be having what? F what? F L all over what? A E. Is that okay? Do you know how we are having this? We have already proven this over again and again. If you want to test it, if it is correct, you can use numbers. Right? Imagine you are having 20 all over 4 all over 10 all over 2. We now say it's what? 20, right? Times 2 all over 4 times 10. Solve this and solve this is the same thing you have. It's simple arithmetic. Is that okay? If you say 20 divided by 4, the answer is going to be 10 divided by this. At the end of the day, the answer, you are still going to arrive at the same answer. Is that okay? So So that's the reason why. I'm sorry. I'm not wiping this. I'm just wiping the. So a young modulus is equal to what? Hello, one house, please. You'll be having young modulus to be what? FL all over AE. So take note. It is very, 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 very important. It is very, very, very important. So we say young modulus is the ratio of tensile stress all over tensile strain. Should you have been asked, state young modulus. It's the ratio of tensile stress all over tensile strain. Is that okay? Now let's look at work done in spring and elastic material. Where is Joy? Where is Toby? You say? It's today public holiday. Joy is not around. Please reach out to them. Tomorrow, if I did not see Princess, I will ask, where is Princess? You can imagine I was shouting Princess to know where she was sitting. And if I did not see Ola, I will ask the mother. I don't know your mother. If I know your mother, I will ask your mother too. So can we go to work done in work done in spring elastic. What is work done? Normally, we say work done is equal to what? W is equal to what? Work done is equal to what? Anybody that did not know work done? Distance is S, right? Is it S or D? But understand this. Now, we say work done is equal to first times distance. Anybody that did not know that, I'll just tell the person. At this junction, I'm through with you. You excuse us. But work done in extending a spring, are we together? Is the average force times extension. I'll put it on the board for you. Work done here, W is equal to the average force times extension. Is that okay? If I'm having 20 as my force, average force will be what? Average force will be what? 10, right? Half. Average. Half. So the formula is going to be half F. You say half what? Half FE. Are we together? So our W will be equal to what? Half FE or KE square. Or half KE square. Average force times extension. Are we together? So should I ask to calculate? Should I ask to calculate the work done? Know this formula. Very, very important. This is all you need. This is all you need. Should I ask to calculate this? And then know how to relate this to what? Potential energy. Potential energy is equal to what? mgh. And kinetic energy. Know how to relate them, please. So in a situation where you are being given height in an elastic question, you should know that they want you to relate it to potential energy. Is that okay? Is that okay? In a situation where you are being given mass and you're having F is equals to work done is equals to half Fe, and they are bringing mass and they are bringing height, you should know they are taking you to kinetic potential energy. And if they are bringing in V and M, you should know they want to relate it to what? Kinetic energy. Is that okay? Can we want to ask a question? Okay.
How do you know when to use half Fe squared or half?
It is from the question. That's the reason why earlier I stated this. I said K is what? Is the force constant or the stiffness of the material. So if it's being stated in the question, good, you know the force constant K is involved.
So the force constant varies or
It doesn't vary. The force constant depends on the material. Is that okay? So the force constant of a spring is not going to be the same with that of other materials. So the force constant will be given. It depends on the material. So the stiffness of a rubber band material is not going to be the same as the stiffness of a spring. Is that okay? Now let's look at, we are going forward, gravitational field. We are through with elasticity. Any other theory that we're having under elasticity, go and read. The one you don't understand, bring it, let's explain it together. Is that okay? So know the formula: tensile stress, tensile strain, Young modulus, Hooke's law. That's all under elasticity. We don't have much. Can I wipe this? What's gravitational field? Thank you very much. Gravitational field is the region where you can feel the force of gravity. Right? There are places that whatever goes up will not come down. Oh. Are we together? There are places that whatever goes up will not come down. Then the force of gravity is not felt there. If I should throw this marker up now, it will come down. Is that okay? Why? It's because of the force of gravity. Why is it not going up? It's coming down. It's the force of gravity that is pulling it down. Now let me ask a question. As big as this place now, or as big as the road, you'll be walking and you can even go and hit somebody. Why is it so? No, it's not necessarily because you are not looking. As big as this place, let's assume it's clear. There's no table, there's no chair, and people are walking. You can see somebody. It's not as if there's somebody here. There's somebody. It's not as if you are blind or I'm blind, though. But you can see we will be walking and we're even about touching ourselves and we'll be dodging each other. That's the force of gravity. I've noticed it several times. Maybe I've not noticed it before. Who is asking? Now, right. Any two particles of matter attract one another. So it's the force of attraction. As they are walking, My force of attraction and your force of attraction. Any two particles of matter attracts one another. Any two particles of matter. Any two particles of matter attracts one another with a force F. You are welcome. Why did you arrive late? Any two particles of matter attracts one another with a force F, which is the product of their mass M1 and M2. Force F with a force F, which is the product of their mass M1 and M2, and inversely proportional to the square of their distance. Which is the product of their mass M1 and M2, and inversely proportional to the square of their distance. Please don't drag us backward. Be focused. Don't allow anybody to distract you. Ola, you are not writing.
I did a short jotting and it's
M1 and M2, which is directly proportional to the square, is inversely, is not directly, which is inversely proportional to the square of their distance. If I say inversely proportional to r square, it means 1 all over r square. Right? Are we together? If it's directly proportional, you are going to have FR is directly. Inversely, you're going to have it all over to the square of their distance. Now we're having M1 here, M2. These are two mass with R. This is what they are saying. Any challenge, don't make noise. Any challenge. Are you having any problem? Yes, M1 and M2, and this is the distance R. We are having two mass here, right? Is it mass or masses? Okay, we are having two mass here, M1 and M2, and this is the distance between these two mass, right? Now, the gravitational field. Now we're not talking about the product of these two mass and the square of their distance. Are we together? Are we together? If I should notice you are distracting my class, you stand up. Oh. Now the gravitational force between two masses will now be having the F to be equal to what? G what? All over R square. Where G is the what? Gravitational constant. Which has a value of 6.6 exponential minus 11 Newton meter. Stop making a Zola. This is the gravitational constant. Please, by now, I hope you all know how to calculate your exponential manually without calculator. Hello? Hello? Please, if you don't know how to calculate your exponential power in the calculation manually, please meet any of your colleagues that knows it. Let them put you through. Is that okay? If you are having something that says 6.6 exponential 34 all over 6.3 times 10 raised to the power of 3. Is that okay? if you are having something like this, you should know how to calculate it manually. All you need to do, you make use of this, right? And then you do this manually. That's what I'm talking about. If you don't have the understanding, meet any of your colleagues, let them teach you, because the calculator you are using is not a scientific calculator. Is that okay? We are just using scientific calculation for the class, but outside the class, when you go for JAMB, you not see something like exponential. It will not be in your calculator, so you calculate it manually and you still get the same answer. So all you need to do is to say 6.6 divided by 6.3. So whichever answer he gives you, calculate your exponential power manually. At the end of the day, you'll be having the same answer that somebody is having, that is having calculator will be having. Is that all right? Please, I beg you. If you have not known that, make it mandatory for yourself to do that today. Is that okay? So we say our first constant is for 6.6 exponential minus 11 Newton per meter per kilogram. Is that okay? Newton per meter per kilogram. This is it. This is the gravitational constant. Gravitational potential. Are you true with this? Okay, can we move forward, please? So please note this formula. F is equals to G M1 M2, the product of the mass, right? Multiplied by divided by what? The distance, the square of the distance. Note this formula. Very, very important. Please, no noise. Ask questions if you are confused. Ask question, please. And stop making noise. Is that okay? Gravitational. Let's look at gravitational potential. Right, gravitational potential. Right, gravitational potential. Right, gravitational potential. Should I move forward?
No, sir. Yes, sir.
Bathsheba, are you writing? Or are you pressing your phone? Gravitational potential is the work done in taking a unit mass from infinity to the point. Hola? Are you the one reading? Are we using the same notes?
I'm not fully keep it.
As if you come and start continuing this lecture, let me rest.
Yes, I cannot.
From infinity to the point. From infinity. The work done in taking a unit mass from infinity to the point. V is equal to. When you hear something about potential, no V is involved. Potential difference, potential voltage, potential. You know V. Okay, is it what I just read? I said gravitational potential is the work done in taking a unit mass. Taking a unit mass is the work done in taking a unit mass from infinity. Bathsheba is not writing. Is the work done? Are you true?
Yes,
There's somebody that asked at the back. Are you true? Yes, to the point. Bathsheba, ask somebody beside you if you are the one asking. V is equals to what? G M all over what? R. Is that okay? Where your M, this is capital letter M, is equals to what? Mass of the earth. And G is your gravitational constant. Y R is equals to radius of point from the center of the earth. The last time I said that anybody that is able to score more than 75 in physics in JAMB, I'm going to give the person a gift. 75 on the dot. Ask to be for my number. You can give me 75. I promise you a gift. And if you add Jara me too, I'll add Jara for you. Earth. Mass of the earth. Yes, radius of point from the center of the earth. Ola, will you help us fill this marker, please? She's around already. Less the noise. When you see you making noise, I'll send you out. When you see you making noise, I'll send you out. Now we're talking about acceleration due to gravity and gravitational field intensity. And then the formula that relates them, I'm just introducing you to a formula. We'll get problems that we'll apply the formula with. Anyway, you see M, you should know is what? Mass of the earth. And R is what? Radius from any point on the center of the earth. Right? Are we together? Now we says we are trying to relate acceleration due to gravity with gravitational field. Is that okay? And then we're having F is equals to what? MEM all over R is square. We are trying to get what? This G. We say F. You remember we say F. F is equals to what? Mg. Right? Then we say F is equals to mg. G will be equals to what? M all over what? F all over M rather. Is that okay? Now when I say okay, when you cross multiply, hello, if you divide this through by M, this M will cancel this, right? You have F all over M. Is that okay? That's the reason why we are having FM here.
FM.
Are we together? That's the reason why we are having this here. And then note that this is equal to what? F all over M is equal to G. Do you understand? We say but G is equal to F all over M. Therefore, G is also equal to GME all over RA square. So relating acceleration due to gravity to what? To the gravitational field. Now let's look at weight of object in space. Weight of object in space. When an object is on or near, when an object is on or near the surface of the earth, it experiences.
When an object is near.
When an object is on or near the surface of the earth, comma, it experiences surface of the earth. It experiences the full extent of the force of gravity. Extent of the force of gravity or acceleration due to gravity. Of gravity or acceleration due to gravity. I give somebody pen. All the pen I give people, if I give, that's the end. They will not return. 3 now. But this is your own. This your own will not go. Force of gravity or acceleration due to gravity. Have you written that? It experiences the full extent of the force of gravity or acceleration due to gravity of the earth.
Wait, the force of gravity
or acceleration due to
or acceleration due to gravity of the earth. Full stop. However, if the object, put in bracket, if the object, open bracket,
yes, sir.
for example a satellite, close the bracket,
Satellite.
is launched into outer space, at a distance from the surface, is launched into outer space at a distance from the surface or center of the earth.
From the distance of the surface.
At a distance from the surface or center of the earth, comma,
at a distance from the
surface or center of the earth. The weight of the object reduces. The weight of the object reduces because the earth's gravitational force
Yes, the gravitational force reduces. Yes.
because the earth's gravitational force on the object diminishes. This diminish. Where am I coming from? The weight of the object reduces because the earth's gravitational force on the object diminishes in proportional to its distance from the earth. In proportion diminishes in proportion to its distance from the earth. Full stop. Then note, the farther the distance, you know the spelling of farther? It's not farther, as in far. The farther the distance from the earth, the lesser the weight. The lesser the weight. What we are saying is that if I have wing and I can fly now, I'll carry you. Assuming I can fly, right? And I am going into outer space. I'm going into the heaven, right? As I'm going, I'll be weightless. Hello? Hello? Let me give this simple illustration. As I am on the surface of the earth, if I want to measure my weight, my weight may be maybe 50, 60, and now I should be around 70 or thereabout. Is that okay? But if I should leave the surface of this earth, and I am being taken up, and I should measure my weight, it will not be the same thing. The thing will be coming down. From 70, it will come down. Like now, those that have opportunity to go to the moon, if they have a scale and they want to take their weight, you can see some of them to be 10 kg. Why? Because the force of gravity is not being felt very well there. You understand? That's the reason why, that's the logic. You should be wondering, what is holding the satellite in the space? Hola? What is that thing that is holding the satellite in the outer space? Did they tie a rope to it to something? It's because the force of what? Of gravity is not well fed there. That's the reason why, if not, all the satellites in the space, if they fall on us, are we together? Now, right. Example. Let's take one example. Are you writing? If the weight of a satellite on the surface is 2,000 Newton, the weight of a satellite on the Earth's surface is 2,000 Newton. You have the example in your book. This time we are using the same note.
Size what?
If the weight of a satellite on the Earth's surface is 2,000 Newton, what will be its weight when it is 2,000 Newton? N. The unit of force is what? What will be its weight when it is 1 at distance equal? What am I starting? It's the same thing I've been saying. If the weight of a satellite on the Earth's surface is 2,000 Newton, A what would be its weight when it is 1. At a distance equal to the radius of the earth from the surface of the earth.
At a distance.
At a distance equal to the radius of the earth from the surface of the earth. 2. At a distance equal to the radius of the center, equal to the radius of the earth from the surface of the earth. Then 2. At a distance of, we don't have time. We don't
Shall we not write rubbish?
You don't write rubbish. God will not allow you to write rubbish. 2. At a distance of 1.28 exponential 7 meter from a distance of 1.28 exponential 7 meter from the surface of the earth.
That's no, that's constant. Yes, I think it's constant.
3. Okay, it's easy. Okay, I'll not rush again. I'll take it slow. From the surface of the earth. 3. You are not through with the first one. 2. I say at a distance of 1.28. You see, I should be slow and you are making it. But if I'm fast now, you don't make noise. That's the reason why it's good for me to be fast. At a distance of 1.28 exponential 7 meter from the surface of the earth. That's the reason why I don't like taking the example. 3. At the distance equal to 4 times the radius of R of the earth. At a distance equals to 4 times the radius of the earth from the center of the earth. At a distance equal to 4 times the radius R of the earth from the center of the earth. Bishop, are you writing? This one you confess. Final answer you confess. Don't want to struggle and lie again. From the center of the earth. B. For each case. B is coming from the one you write is A. You will not do example again. Don't worry, this example will give you explicit understanding, a good understanding on this topic, that any objective question that come, you strangle it. B. For each case. For each case. For each case in A above. Derive an expression for the acceleration due to gravity. For each case in A above, derive an expression for acceleration due to gravity. For acceleration due to gravity. In space. Derive an expression for the acceleration due to gravity in space with respect to the acceleration due to gravity on Earth? Radius of Earth
In space.
in space with respect to gravity on Earth. Is that okay? Then radius of Earth R is equal to Ola. This marker the 6.4. This is the radius of the Earth. So from what we have done so far, meter. Radius is in meter. You did not understand what I wrote. Okay. Allah, you want to solve for us?
No, I'm explaining something to you. I cannot teach that. I am the best.
No, I'm not saying you should teach. Come and help us solve this question. You want to try?
Let me try. I'm not sure. I'm not sure, but let me try.
We don't have time. Mother, don't worry, we don't have time. Somebody say we don't have time.
God bless you. Don't be right.
From the question, the weight is what? Weight is what? What is the weight of the satellite in space? Mass of the Earth. Then mass of the satellite. Ola, stop making noise. Is somebody writing? Yes. What are you writing?
Sorry for you. Didn't get our prize. Yes.
We have A1. A1 says what? This is the Earth, right? And this is the satellite.
Yes.
Ola, stop making noise. Are we together? Now this R. This R is the radius of what? The Earth. And we are having, they say, A says what? What is the distance between? The distance from the center of the Earth. At a distance. Please, this question we are solving is very, very important. They can just ask you to find A. They can give you a question like this and they'll tell you what is the distance between the satellite from the surface of the Earth. Right? Now, the distance from this point to this point will be the summation of both R. Are we together? Which will give you what? R plus R. Is that okay?
No, sir.
Who is saying no, sir? What is the name? What is the name? Genevieve. Jesus. We get celebrity for class. Genevieve, you say you don't understand. Don't worry. I'll still explain it again. Now we are having this as what? The earth, right? And we're having this what? The satellite. The mass of the earth. Don't worry. As you are going, you know the mass of the earth. Now, they says, question number 1 is say, at what distance? At a distance equal to the radius of the earth from the surface of the earth. And they are relating it to the satellite, right? And they say the weight of the satellite is what? On the surface of the earth is 2018. At distance, we are talking about the radius, the distance. When you hear R, what are they talking about? The distance. Is that okay? Now they says at a distance equal to the radius of the earth, that distance, if this is the earth and this is the satellite, the distance of the earth from the satellite will be summation of these two R. Now, hello. Allah, why you saying ah?
Why you say ah? Why you say ah?
Now, hello. Please understand. We are having. Allah, stop it. We are having the satellite here, right? And let's assume from here, from this point to this point is term B, right? And we are having this radius R. For you to get the distance between these 2 points, you have to add this distance plus this distance to get the total distance. And in this, you can say it's equal to what? R plus B. Where B is the distance between this point and this point, and R is equal to the distance between the radius of the earth. Is that okay? So don't allow the 2R to confuse you. Are we together? Don't allow the 2R to confuse you. But what they want you to know is that we are having 2 distance. Because the satellite is outside the earth. It's not on the earth's surface. Is that okay? The moon you are seeing, the moon is not inside the earth. The moon is outside the earth's surface. If you are having, you already did 9 planets and you see how they revolve around the sun. You see the position of the sun, see the position of the moon, and the position of the rest of the planet. The earth is just what? Is revolving round the sun. So if this earth will turn now and is backing the sun, it means in this our side we will not have sunlight. But in other parts of the country, it is their morning.
Yes.
If this guy is Mr. Sun, I am facing it, and this is Nigeria. Yes. Nigeria will have light.
Yes.
Right? Nigeria will have sunlight. Hello. Nigeria will have sunlight, right?
Yes.
And as I am turning like this,
yes,
you see, before you know, it will be night.
Yes.
And when I'm backing him, another country that is here
yes,
is enjoying the sun. Is that okay?
Yes, sir.
So please note, satellites are not on the earth's surface. Moon and the stars and the rest, they are not on the earth's surface. We are just seeing them from afar.
Yes.
Is that okay? Now they say it here. The distance of the stop making noise. Please write. Please write. Everything I'm giving you is explaining the solution to you. So write. Or should we leave this example?
Yes, sir. No,
Why will you say yes? You said what?
Yes,
So I would say yes, we need to save time.
sir, I don't mind Allah, no, sir. Yes, sir.
Because I know my you need to save time. You know how many sorry to pay on that feelings.
I mean, it's a good that, sir.
Yeah, I think so. You know what I want. You know what I want.
Stop making noise. Hello. 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 Use this question as assignment. Yes. And if you cannot, if you don't, if you really want to solve it, meet me. Let's solve it together. Is that okay? Let's move forward. These are people are making noise. It seems you are not interested. So let's move forward.
What? Where did I do?
Allah, keep quiet.
I just stated
Allah, keep quiet.
They say
Keep quiet.
they pay you inside.
Escape velocity.
Yes, sir.
What are you writing again? It's assignment. You don't need to write it. Somebody asked of escape velocity area, right? So what is escape velocity? You asked of escape velocity area.
Let me explain.
Yes, that is
This one amount of force or energy
required for
or object.
an object or satellite to escape. Clap for yourself. Clap for yourself.
Did you hear what he said?
No, sir.
Say it loud so that I can hear.
Stand up and say it. Stand up and say it.
I mean, escape velocity is the amount of energy required
The amount of energy required
for an object or satellite to escape,
for an object or satellite
to escape the gravitational field of the Earth.
to escape the gravitational field of the
I
earth.
disagree with you.
You disagree?
Yes.
You did have a contrary definition.
Yes, sir. He said that it's energy. Escape velocity is no. Are you listening to me?
Hello? Hello? Right. Escape velocity is the minimum velocity.
So yes, it's velocity, not energy. Are you yes? Anyone. It's not anyone.
It's the minimum velocity. I've given somebody my pen already. Bros, don't forget to give me my pen.
Correct my pen.
Escape velocity is the minimum velocity
So you need 10 now. So you need a 20.
with which an object
Why your voice not
with which an object will just what are you doing? Would just escape from the influence. Would just escape from the influence. Would escape from the influence. With which an object will just escape from the influence of the Earth's gravitational field. Gravitational field is the region where the gravitational force is being felt, right? So it's still the same thing. And it says VE escape velocity. Escape velocity equals to what? Square root of
capital R.
Finish.
Where R is the radius? Which one all over R? Shut up, boy.
hello. Please stop making noise. This is the formula for escape velocity.
Thank you, sir.
Now welcome.
Eh? It's not. There's different. Hold on. It's small g. The difference between this g and this one.
Thank you. I didn't specify.
From the formula I just gave you, I say g is equals to what? I say g is equals to what? Eh? It's equals to what? G is equals to what? All over what? The root of what?
Yes, you can. Then you change it. You can use that formula. You can use
I can change.
You can use this formula. You can use that one. This is 2GM over R. 2GM. Yes. Then the number is 2GR. You see it?
Thank you. Hello. Hello. From where we are coming from, we said what? We have G to be what? And then we say if G is equals to F over M, then G is equals to what? GM over R E square. Now, can we impute this into this formula?
Yes,
So do it. What are you going to have?
V is equal to square root of 2 capital G M E over R. R E R. No, it's not square. It's square is going.
over R.
It's over R.
We'll be having what?
Root 2GM.
Root 2 GM over R. So does this define your this thing? This is how they got to. From here, we have G is equals to F over M, and I say G is equals to this. If G is equals to this, and you are imputing it in this formula, automatically it's going to change.
Yes, sir. We grabs.
Do you understand?
Yes, sir.
So don't ask me, sir, how did it change from GR to GM all over R? This is the magic they did.
There's no magic.
It's no magic. This is the calculation.
Logic is different from magic.
You are sleeping. Yes. Gravitational due to acceleration due to gravity, small g. Then gravitational constant of the Earth, which is 6.6 exponential 7 meter. Gravitational constant. Is that okay? So the small g is 10 meter per second. That's the one. That's the one we are saying. If you throw something up, is that okay?
Yes, sir.
Okay, let me give you this objective question. Take it. We are even supposed to start chemistry now. They say it should be.
So we are starting chemistry.
Okay, take this short example. Take this short example. Take this short example. What is the escape velocity of a satellite launched from the Earth's surface?
What is the escape?
What is the escape velocity of a satellite? Genevieve, do you like Ola?
It's very annoying.
Okay.
Annoying.
Why is it? You will not kill him before night. What is the escape velocity of a satellite launched from the Earth's surface? Earth's surface. Take small g as 10 meters per second. Take the radius of the Earth as 6.4. Take small g as 10 meters per second. 10 meters per second. 10 ms. And radius of the Earth at 6.4 exponential 7 meter. Is that okay? 6.4 exponential 7 meter. Radius of the Earth r.
6.4.
Exponential 7. Did I say minus 11? 6.4 exponential 6. 6.4 exponential 6. There's no minus there, please.
And the answer is 1.
Somebody is already giving me answer. Which formula I need to use? 2GR. That's the reason why you need to understand these two formula. See these two formula. Because we are given G, we are given R, but we are not given M. So you don't have anything to do with the other formula. Is that okay? So the formula you need is this. The root of what? 2GR.
Minus 8.
Which is equal to what? 2 times 10 times what? 6.4 exponential 6. So your answer is going to be
1.13 times 10
minus 8.
1 point what?
1.13 times 10 to power minus 6.
Let's say about this of princess this of Genevieve. What is our answer?
Minus 8. Minus 8.
The answer is what?
1.13
Minus 8.
exponential 4.
Okay, silent is correct.
Why are you not solving? What's the answer? I'm waiting. Okay. Hello. Hello. Now I want to test your knowledge. What if you are being asked? You are the one pressing calculator. I'm not having calculator to press. Why you having different answer? Tell me the answer you are having. 1.1.
1.13
Same as
It's a meter per second.
thank you.
You're welcome.
When I say to the
Is this the answer you are getting?
Yes, sir.
Eh?
Yes, sir.
yes, sir.
Is this the answer you are getting?
Yes, sir.
Who is having contrary answer?
Don't get to write your comment.
Did you take the root?
Yes,
Yes, we take you.
Yes, sir. Nice answer.
That is the answer. Don't answer.
Is anybody having contrary answer?
Yes. Well, let's propose.
Where's the calculator? It's not the answer.
That's the answer. You don't get that answer, right?
Sir, I know what they are getting. They are getting 11313 point something. You are getting don't take it back.
Why you take it back? They are not taking it back.
They are not taking it back.
Hello.
Like, it's okay.
Stop making noise, please.
They are getting half.
This is what I'm getting, but if you know that you have to
It's not compulsory, but
Tell me the answer in a normal 1 point. Normal figure. 1 1
3 1
3 1 1
just like that.
1 1
3 1 0.78 0.78.
Okay. Please standard form for this.
1.1.
You need to know how to solve standard standard form as well. Maybe it's from the phone.
Got the back.
I used phone before giving me another.
That's your correct.
that's your problem, man.
It's 11. 11 point what? Just 11. 11.3. Your answer is what? You're having 11.3. Is there any exponential power?
Yes, sir.
What's the exponential power?
I know grabs.
Let's get the answer.
It's 6. Is that what you're having? Hello. Hello. This is the reason why I don't like taking examples. Because we want to use it and make noise. Do you? Hello. I don't have a calculator to calculate. What I know is that this is how to solve it.
Yes.
This is how to calculate. Is that okay?
Yes, sir.
Now, I want to ask you a question. What about in a case when you are being given a diameter? Right?
Divide by 2. Radius is.
Hello. In a case where you are being given the diameter and you are supposed to use radius, what you do? You divide the diameter by 2 because assuming you are having this is a circle. From here to here is radius. From here to here is radius. Everything is diameter. So if you divide by 2, you have your radius. Is that okay? Is that okay?
Yes.
This is the reason why I don't like taking example. I didn't mean we do not take example now, we would have gone far. Then you do the example for yourself. God forbid, go on like this. I think that's all for gravitational field. Please. Hello. Hello. Our next topic is going to be radioactivity.
Yes. No.
What's the time?
Why is your time different? All of you man set up to go and buy
Is it calculator time you are telling me?
Yes, so
Okay, right. Radioactivity is defined as the spontaneous disintegration. Radioactivity is defined as the spontaneous disintegration.
Yes, sir.
Spontaneous. Write that spontaneous anyhow, don't worry. I'm not marking the note. As a spontaneous. Yes. Spontaneous disintegration. Radioactivity is defined as a spontaneous disintegration of an unstable atomic nuclei. Of an unstable. Hello. Please don't make noise so that you can hear. If I shout too much, my voice will be cracked. And you don't even hear me at all again. Allah, you can help me. Spontaneous disintegration of an unstable atomic nuclei. What is the difference between nucleus and nuclei? Eh?
Normal English. Nuclei is singular.
Which one is singular? Is there anything like that?
No, nuclei.
I'm asking, is there anything like that? Are you sure?
I've not heard of anything like that.
You have not heard nucleus. You have not heard nucleon. Of an unstable atomic nuclei with the emission of alpha, beta, or gamma. With the emission, stop making noise. Hola. With the emission of alpha, beta, or gamma radiation. Just write the symbols. This is what? Alpha, beta, and gamma. Is that okay? Beta is something like this. Radiation and release of energy. When radioactive element every radioactive element has its unique decay constant and a half-life. Has its unique decay constant and a half-life. Every radioactive element has its unique decay constant and half-life. Radioactive is sure. You must see it in your exam whether you like it or not. You cannot jump it. Has its unique decay constant and half-life. Is that okay? Now, right. The disintegration. Yes, full stop. Yes, half-life. That is somebody with a half-life. Half of somebody's life. So I'm supposed to live 200 years now. Half-life now. The disintegration or decay of a radioactive element. The disintegration or decay of a radioactive element It's a random process that is totally independent. It's a random process that is totally independent of chemical combination. Random process that is independent of chemical combination, temperature and pressure. It's not affected by chemical combination, temperature and pressure. You are still in a random process. It's a random process that is totally independent of chemical combination, temperature or pressure or and pressure, whichever one you want, wherever one you want to write it. Full stop. It occurs. We don't have time. I'm only having 6 minutes to round up this. You are saying yes. I said I'm happy. Don't want to do reductive. And this topic is as if it's in chemistry, Abi.
Yes.
In university, we combine with a chemistry student to do this particular topic. It's what? It occurs when an unstable nucleus, usually with atomic number greater than 83. It occurs when an unstable nucleus, usually with atomic number greater than 83. Element with atomic number that greater than 83 are what? Call them for me. Unstable nucleus, usually with number greater than, usually with atomic number greater than 83, undergoes natural decay greater than 83. Undergo natural decay in a bid to achieve a stable condition. In a bid, BID. In a bid, BID, or for the aim to achieve a stable condition. It's English, don't confuse yourself with it. To achieve a stable condition. Stable condition, oh. Okay, right? A typical decay curve for a disintegrating. What if you are attending biology class? You don't write? Okay, biology. How many human bones? How many bones are we having in the human skeletal system?
How many
Bones.
in the human
Skeletal system. It's divided into two. How do you get the two osis? What's axial skeleton? What's perpendicular skeleton? Right. A typical decay curve for a disintegrating radioactive. Decay curve for a disintegrating radioactive atom. Curve. Genevieve, right. This one I want to write now, you need it. Decay curve for a disintegrating radioactive atom. Obtained by plotting the number of atoms. Where are you? Typical decay curve. Should I move forward? For a disintegrating radioactive atom. Disintegrating radioactive atom obtained by plotting Can I move forward? The number of atoms, the number of atoms, the number of atoms present against, can I continue? Present against half-life. Full stop. If the initial number of atoms is n1 at time t1, if the initial number of atoms is n1 at time t1, if the initial number of atoms is n1 at time t1, right? And falls to n1 all over 2 and falls to n1 all over 2 at t2, and falls to ability n1 all over 2 at time t2, then the half-life t is given by, then the half-life t is given by, t is equals to, is given by, the half-life t is given by t2 minus t1. Minus t1. In the same manner, the half-life is also given by t is equals to t3 minus t2. In the same manner, the half-life is also given by t is equals to t3 minus t2. 3 minus t2. If the number of atoms reduces from n1, if the number of atoms reduces from n1 all over 2 to, the number of atoms reduces from n1 all over 2 to n1 all over 4. See me, I don't come back. Eh?